In this video, I want to answer a simple question. What is predictive AI? You have probably heard a lot about AI lately. ChatGPT, image generators, self-driving cars, you name it. But there is quieter, older, and honestly more economically important branch of AI that's been running in the background for years. It decides whether you get a loan, or it flags whether a patient needs follow-up care. Another example might be that it shapes which jobs application even get read by human. That's predictive AI, and that's what we are going to unpack today. Let's start with a question. What even is a prediction? Geoffrey Hinton, one of the founding figures of modern AI, by the way, put it pretty simply. He said, take any problem where you have to predict something and you have enough data, and deep learning will probably outperform whatever you were doing before. That's the key insight economists Agrawal, Gans, and Goldberg made back in 2018. Recent advances in AI are essentially a massive drop in the cost of prediction. And because prediction is a core input into almost every decision we make in business, in medicine, and policy, that has enormous consequences. So what does the prediction process actually look like? In very simple terms, you start with historical data, past loan repayments, patient records, student grades, you name it. You feed that into an algorithm, which finds patterns, which features tend to predict the outcome you care about, and then you get a forecast, a score, a probability, or even a classification. And that's it. That's the engine underneath predictive AI. And now, before we go any further, let me clear up a confusion that comes up constantly. When most people hear AI today, they think of ChatGPT or DALL-E, tools that generate new content. That's generative AI. It's impressive, don't get me wrong. It's getting a lot of the attention. And it works by learning the distribution of huge amounts of training data and then producing new outputs from that distribution. Predictive AI is different though. It's not trying to create anything new. It's trying to forecast something that already has a right answer. Will this borrower repay the loan, for example? Will this patient be readmitted to hospital? Will this student fail the exam? The outputs are scores, probabilities, classifications, not text or images. Both are important, but predictive AI is often the less visible one, quietly making consequential decisions that affect real people's life. That's why it deserves its own discussion. So, how does predictive AI actually work? There are four basic steps which I'm going to show you right now. First, you collect the data. The algorithm needs examples, as we discussed before, of past cases where you know the outcome, thousands or even millions of them. Second, you train a model. The algorithm goes through the data and learns which features are statistically associated with the outcome. It might be income, it might be repayment history, or even zip code. These all might predict whether someone defaults on a loan. The model learns those relationships. Third, you validate it. You test the model on data it hasn't seen before to check how accurate it actually is. You tune it in, you adjust it until it's reliable. And fourth, you need to deploy it, obviously. New cases come in, and these could be new loans applications, new patients, depends on the domain itself. And the model outputs a prediction. The specific methods vary. You might use a decision tree, or random forest, or even a neural network. But the logic is always the same. Learn from the past, predict the future. Let's look at where this is actually being used. First example, healthcare. Hospitals use predictive models to identify patients who are likely to be readmitted within 30 days of discharge. A high-risk scores trigger follow-up calls, extra monitoring, or a home visit. Research in Scandinavian hospitals shows how these systems are built and how the definition of what counts as correct prediction turns out to be surprisingly contested among clinicians who build them. In education, another example, universities have experimented with predicting which students are likely to struggle. They used grades, they used attendance and other background data. and the instructors could intervene earlier based on this data. A study at Technological University in Monterrey in Mexico tried exactly this with engineering students, and they used random forest and k-nearest neighbor models. The results were really promising, though the researchers found the model needed more data to make reliable individual predictions. We're talking about the individual level, even if it gave a useful picture of the group overall. So the potential is real, but so are the complications, which we will come to. And two more areas are worth mentioning: predictive AI in finance and public policy. In finance, credit scoring is probably the most widespread application. Machine learning models assess loan default risk using thousands of variables, far more than a traditional FICO score ever could. In principle, this is great. It can expand credit access to people who would previously have been rejected based on a thin credit histories. But, and that's important to mention, it has also created a real risk of encoding historical bias into automated decisions. More on that in a moment. In public policy, a fascinating example comes from Italy. Researchers used decision tree models to identify households that were consumption constrained, so essentially struggling to make ends meet, for the purpose of welfare targeting. The machine learning approach outperformed the traditional method of using a handful of arbitrary chosen characteristics. It's a concrete example of how predictive AI can, in principle, make government more effective. Now, let's zoom out and look at the economics. A major survey published in early 2026, covering over 5,000 CEOs and CFOs across the US, the UK, Germany, and Australia, paints an interesting picture. Around 70% of firms are already using some form of AI. But here is the thing. So far, the actual impact has been small. Over 80% of business report no measurable change in employment or productivity over the past 3 years. However, and this is the key point, firms expect that to change dramatically. They forecast AI will boost productivity by around 1.5% over the next 3 years, while reducing employment by about 0.7%. That's a significant shift, and it hasn't happened yet. There, there is also a striking disagreement buried in the data. Executives at those firms expect AI to reduce headcount, but when the same researchers ask the employees at those firms, workers expected AI to increase employment. Same technology, same company, completely opposite expectations. That gap alone tells you how much uncertainty there still is. All right, let's talk about the part that often gets glossed over in the excitement around AI, the dark side. In 2018, Amazon scrapped an internal hiring algorithm after discovering it was systematically downgrading CVs that included the word women. Because it had been trained on 10 years of historical hiring data, and historically, most tech hires had been men. The algorithm learned the pattern and reproduced it. There is Compass, a tool used in some US courts to predict the likelihood of reoffending before a sentencing decision. An analysis by ProPublica found it was flagging black defendants as high risk at nearly twice the rate of white defendants, even controlling for actual recidivism. The algorithm wasn't intentionally racist. It was trained on data from a system that had structural racial disparities built in. A 2025 paper in Social Psychology gives this a name: AI as moral cover. The argument is that organizations adopt biased AI tools while genuinely believing they are being objective. And that's actually more dangerous than explicit discrimination. Because if a human makes a biased decision, you can challenge them. But if an algorithm does it, it looks like a neutral, objective output. The bias hides behind the math. The root cause is the same in every case. Predictive AI learns from the past. If the past was unfair, the model will be unfair, and the output will look scientific. The inequality problem doesn't stop at the individual level. It also plays out between countries. An International Monetary Fund working paper from 2025 looked at how AI-driven productivity gains are likely to be distributed globally. The numbers are striking. In advanced economies, around 60% of jobs are highly exposed to AI, meaning they involve tasks AI can assist or automate. In low-income countries, however, the figure drops just by 26%, and the projected GDP gains reflect that. Advanced economies, the US in particular, are looking at potential gains of around 5.4% of GDP over 10 years. Low-income countries, around 2.7%. So, not only do they start from a weaker position, they also capture less of the upside. The IMF researchers found that better digital infrastructure and stronger institutions can help close the gap, but probably not fully. Without a deliberate policy, AI risks becoming a new fault line in global inequality. So what should governments actually do about this? Four things stand out. First, transparency. Require algorithmic audits for high-stakes decisions. If an algorithm is deciding who gets a loan or who gets a job interview, citizens should have the right to know and to challenge it. Second, regulation. The EU AI Act, passed in 2024, is the most ambitious attempt so far. It classifies AI systems by risk level, and uses like credit scoring, employment decisions, and criminal justice are considered high risk, with strict requirements for transparency and human oversight. Third, access and infrastructure. Countries that lack the digital foundations, reliable internet, data infrastructure, AI education, will struggle to benefit at all. Public investment here is not optional. And fourth, human oversight. Predictive AI should be a tool that helps humans make better decisions, not a replacement for human judgment. Especially in consequential decisions, a person should always be in the loop. Let me bring it all together. Predictive AI is, at its core, a machine for making cheap predictions. It learns statistical patterns from historical data and uses them to forecast future outcomes. It's already embedded in healthcare, finance, education, and public policy all around the world. Economically, most of the gains are still ahead of us. Firms are optimistic, but the productivity boom hasn't arrived yet. The risks are real and already visible. Biased training data produces biased predictions, often invisible to people affected. And globally, the countries the best positioned to benefit are already the wealthiest ones. Which brings me to an open question I will leave you with. Who decides what a predictive algorithm is allowed to decide? That's not just a technical question, it's a political and ethical one. And the answer will shape a lot of what comes next. The things that I have mentioned in the video, all sources are listed here on the slide and will be included in the submission. The full reference list includes 8 academic and policy papers from 2018 to 2026. Thank you so much for watching this, and if you have questions or comments, I am happy to answer them.